This week on the Tech ONTAP podcast, we talk about Cloud Volumes EdgeCast with Jaap van Duijvenbode.
Welcome to the Tech ONTAP podcast with Justin Parisi.
I love NetApp.
Oh, yeah.
NetApp. I love this company. Support.
I love NetApp because it's so funny.
Hello and welcome to the Tech ONTAP podcast. My name is Justin Parisi. I'm here in the basement of my house, and with me today I have a special guest to talk to us all about caching in the cloud, on-prem, wherever, right? So Jaap, or is it Jaap or Jaap?
It's Jaap. It's perfectly
Jaap.
fine. Thanks,
all right,
Justin.
Jaap. So yeah, it looked Dutch, and the J is a Y, right? So, and then I'm going to attempt the last name here. Van Duijvenbode.
That's like 99% correct. That's great. It's Van Duijvenbode. It's typical Dutch name.
Duijvenbode, that's right.
Yeah, it dates back to the 1400s, so I'm not going to blame you. It's great to be here on the show. My name is, like you said, Jaap van Duijvenbode. I'm a principal technologist here at NetApp and cloud evangelist, and what I focus on is helping customers to solve the challenges around distributed storage and help them in their journey to the cloud to be able to kind of migrate their file services off premises into hybrid or public cloud. So that's a bit about me.
All right, so if we wanted to reach you, how do we do that?
Well, I got a few social media channels. You can look me up on Twitter at JV or on LinkedIn. Find me there. I'm going to kick off with some Discord and Twitch stuff later onwards, and you can find my stuff on YouTube as well. So I have a YouTube channel with all kinds of cool videos, walkthrough demos, overviews, but also some technical in-depth stuff.
You mentioned migrating to the cloud or from the cloud or whatever. So why would someone want to do that? What are some of the use cases that you're seeing out there where people are really taking a serious look at moving in or out of the cloud?
Yeah, I think a lot of companies, they've been dealing and challenged with managing distributed storage for decades. When I started in IT, I started in the Novell days. Some of you may still remember. That gradually evolved into Microsoft Windows NT and Windows servers, and all of that data has kind of sprawled over the decades, right? So we see customers that have distributed environments with a lot of distributed locations, remote offices, branch offices, construction sites, manufacturing plants. And that data has grown organically over time. And they see exponential data growth issues with regards to unstructured file level data. And for many, many years, organizations have been trying to manage those islands of data with local backup, local data management, local security. And it's a pain in the neck because a lot of customers, they can't really deal with the ramification of the exponential data growth that comes with it. So they want to leverage the cloud to subsequently make the data a little bit more intelligent, right? So instead of worrying about blocks and clusters and storage and data management, they want to protect and secure their intellectual property and the information that that data represents. So basically, our customers and the discussions that I'm having are typically around streamlining storage infrastructure and the cost associated with managing that infrastructure, and subsequently being able to augment and leverage the cloud for that purpose, to put more structure around the unstructured data sets that they're managing.
So another challenge that you've touched on a little bit, but when you have a very, very large data set, like multiple petabytes of data in a data lake or something, you don't necessarily want to move that entire thing. You only want to move the stuff that you need. And I kind of equate it to like if you go on vacation, you don't bring your bed, right?
No.
You bring a suitcase and you bring some clothes, right? So You don't always need to bring all your data with you. So what do we have out there that helps us take that concept of a data lake, but shrink it down a bit so we don't have to move so much data? It doesn't cost us as much to migrate.
Yeah, I think that's a great topic. You put that really well. You don't want to bring your bed and you don't want to bring your garage and all. Truth be told, 80% of a customer's data is unstructured. And off that workload, we typically see that only 2% of that data is actively used on a day-by-day basis. So traditionally, customers would just throw disk shells and storage at that problem of data growth and the ability to present that data locally in distributed locations or in data centers. But the majority of that data shouldn't even be there, right? So if you look at 98% of the data, it shouldn't even be on primary tier one storage. Right? It should be out there somewhere in a deep archive, or should be in a cold object tier that could be leveraged for the purpose of long-term data retention. And that's what customers really love about the idea of the hybrid multi-cloud message that we deliver, and these types of options for us to integrate different technologies to put more structure around that unstructured file data set, but also around the cost and the impact of cost on that exponential data growth we're talking about. So combining tiering capabilities in the cloud, combining lower cost object storage and leveraging primary SSD for performance tiers and combining that into a single set of data, which becomes your primary file system in the cloud. That is something that our customers have articulated over the years to say, hey, we would like to get through this perfect world scenario of centralized single set of data in a public cloud or in our data center, and to have the ability to better manage it, better protect it, secure it, monitor all of the things that we need to do with that data, but not pay premium as if everything sits on a tier one storage platform, but really leverage the cloud for the purpose of scale, flexibility, and also lower cost storage.
So what does NetApp offer for that type of use case? What do we have that can automate that to make sure that you don't have to move things on your own? Everything is done programmatically through this option that we have.
Exactly. And that's what we want to talk about today. Cloud Volumes Edge Cache is the latest addition to the Cloud Volumes ONTAP portfolio that combines our Cloud Volumes ONTAP storage platform in the cloud, our backup and recovery services that are now offered through BlueXP, and subsequently what used to be our global file cache technology. And global file cache still is available today as a standalone product, but it's now fully automated and integrated within Cloud Volumes Edge Cache, also short called CVEC. So I'm going to reference to that to CVEC. And CVEC has been built to give customers the option not only to better manage their data and storage assets, but also being able to leverage caching technology to cache only what is actively used at these edge locations. And an edge location can be a distributed office, a remote office, branch office environment, but also regional data centers that you may have where you're running your file services. And the benefit of caching is basically you can present multi-petabyte file sets, but only cache a number of terabytes at a specific edge location, only what is needed and what's relevant to that specific location as users are consuming that data either on demand, as they're browsing through their file shares and their folder structures, as they're opening large files, traditional office documents, large CAD drawings, complex 3D models, and designer data. They actually find the benefit of local performance with the consistency of a global file system and a global file set. And that's what makes Cloud Volumes Edge Cache really unique in our portfolio, because this doesn't only talk about the cloud. It doesn't only focus on the principles of the hyperscaler and the integration of storage and data management, but it extends out to the edge where the users reside, where the users, the applications, and some of these services are interfacing with that data on a daily basis. And to be able to give local type of performance in those locations with the consistency and the coherence of a single file set really adds a lot of benefits for customers. Gives them the benefits of consolidation. They can lift and shift their traditional monolithic Windows file server storage away, move that away from their branch office environments, move that into the cloud, replace that with a cache, and drastically streamline and reduce the cost of ownership with regards to that infrastructure and the data management that goes with it. And then as a result, which is something that is often spoken about in our EBCs and workshops, is if you get to that idea of a centralized single set of data or a single source of truth, you now have the ability to collaborate in real time. So if you're an architectural firm or a construction firm and you're working on large design files, CAD files, 3D models, you can now collaborate across the globe on a single set of data with the full coherence and consistency of that data set, which means that through file locking, through local caching, through streaming of Delta blocks over the wide area network, you can provide a local file system with a consistency of a global file system in the cloud, which gives the users the capabilities to work either as in a follow the sun type of mechanism or in real time with multiple offices as if they're all sitting in the same office, which makes edge caching really unique in terms of how that enhances your productivity capabilities while it eliminates the challenges of the IT administrators and of those that have to manage all of those assets to move everything centrally so you can perform all of your data management tasks, your compliance, your governance, all of that centrally in the public cloud. For the last decade, we've been working with customers to help them in their journey towards consolidation. So think about an engineering firm that goes into an airport terminal, they put in this big laser scanning device, and it basically uses a software package that subsequently translates the actual point cloud laser scan data into a 3D model. You're talking about multiple terabytes of data within a few minutes and hours you can see massive increase in terms of the data that is being generated offsite, and that has to be ingested somewhere. So think about the concept of massive data that gets created through drone images on construction sites or telemetry in motor racing. For example, with Porsche Motorsports, we've done a project to help them move multiple terabytes of data from the racetrack to the factory, process it in the cloud, and make better decisions to start winning races. So all of that goodness comes together, especially as it evolves around large data and large file sets, and specifically file shares, right? How do you make file shares available on a global scale with local performance? And I think everyone on the session that's listening understands some of the ramifications of the SMB protocol, or some of us may still refer to it as CIFS, but that's a highly chatty protocol. So if you're using that protocol over the wide area network, you're kind of dead in the water, because every millisecond of latency has a compounding effect on performance, and it degrades the performance because every single SMB block needs to be acknowledged in sequence in order to get it across the wide area network. So by leveraging caching and streaming and optimizing that data movement and the data transfer over the wide area network, you're able to not only maintain the principles and the construct of the SMB protocol where the users will interface with that data, but you're eliminating the chattiness and the constraints of high latency and low bandwidth in order to provide that local experience with the consistency of a global file set. And that's why large file shares, engineering, construction, manufacturing, design, all of those different verticals make a perfect fit for this technology, but also financial institutions that deal with large Excel files that need to collaborate over the wide area network between Asia Pac, EMEA, and the Americas to make better decisions in investment trading portfolios, etc.
So let's talk a little bit about how this actually works. I would imagine that the edge caches themselves are read-writable. Is that accurate?
Yeah, so basically the way that Cloud Volumes Edge Cache is presented is available in the marketplace. So if you go to, let's say, Microsoft Azure, you want to enable Cloud Volumes Edge Cache, what you get is a storage platform built on Cloud Volumes ONTAP with backup service embedded within the offering. Then subsequently, we're extending that capability of that central storage platform through what we call our edge caching software. That edge caching software runs on Windows Server and provides what we call a virtual file share at the edge location, which means a user would be able to map a drive or kind of access their global namespace to be able to interface with that local version of the file system that is centrally stored and protected and managed in CVO in the cloud. So by leveraging Windows Server as the base platform for this software, as you deploy the software either on commodity hardware or on a hypervisor infrastructure, you now create, I'm not going to use the word replica, but kind of a real-time view of your central data set through a local SMB file share that is accessible to the users. And the way that this technology works, it basically, like I said, integrates with a global namespace like DFS namespaces. So it's really built for the Microsoft enterprises where users are used to their yellow folders, their Windows Explorer view, their drive mappings, to be able to access that data on their file server. But now their file server may be thousands of miles away or hundreds of milliseconds away, but then still maintain that local aspect of performance through caching, which we use the NTFS file system on Windows Server to cache the active data sets either on demand or through what we call pre-population. And the benefit of being a file-aware solution or file-based technology is that you augment and you leverage all of the principles of the SMB protocols, so all of the different versions and dialects, but also the NTFS file system, which includes obviously the data itself, the metadata, but also the extended attributes and the permission structures as you would know them from the Microsoft world. So unlike other technologies in the marketplace that try to solve this problem around distributed storage, we don't have to mimic CIFS or SMB. We're natively sitting on the Windows platform to be able to deliver that experience to the users. We don't have to decouple metadata or replicate metadata between different sites like other vendors do in order to make a solution as such work, which makes it highly scalable, but also flexible to deploy. We have customers with maybe 5 sites and 20 terabytes of storage, and we have customers with hundreds of sites globally and multi-petabyte environments where they're collaborating around the globe 24/7 by 365 in order to get their productivity up to 100% level. So that's obviously where Cloud Volumes Edge Cache solution really thrives. It brings two worlds together. It brings the cloud world together with the Microsoft world, where customers are used to managing Windows Server infrastructure. Instead of managing a file server, they're just managing a Windows Server with a cache, and that subsequently correlates and coexists with additional roles and features that you might require in your environment. So think about software distribution, think about AD, DNS, DHCP, or infrastructure roles and services that you may need. You may already have a Windows Server for today. You could refactor that and repurpose that as a file cache that is much more intelligent, requires way less management, doesn't require any backup because all of your backups have now been centrally consolidated, and also is very low cost in terms of infrastructure footprint as it runs on commodity hardware or on your existing hypervisor infrastructure.
As I understand caching with this sort of workload, the hard part is not getting the data to the edge. The hard part is dealing with the locking in the SMB protocol. How does CVEC handle that global file locking? How does a lock from site A get honored on site C halfway across the world?
Yeah, that's a great question. It's a topic that comes up a lot with our customer conversations, that I want to introduce better ways of collaboration, because historically speaking, we've never been able to effectively collaborate on large traditional file systems in such a way, right? So if you ask Microsoft, they want you to put all of the data in SharePoint and use check-in, check-out, and document management, document control. And, this sounds a bit utopian. I think a lot of customers want to get to that state of managing everything in a more structured manner, but we do know that 80% of the data is indeed unstructured, and file services are here to stay. And that's what I'm seeing in my conversations with customers. The file services estate continues to grow. We just have to make more intelligent decisions around how do we present this to our users, and how can our users get more value out of a file system. And some parts may end up in OneDrive, other parts end up in SharePoint or document management, document control types of environments. But the majority of our workflows and our workloads are associated with that unstructured data set. So yeah, to your point, file locking is critical because it maintains and it guarantees data integrity for users that are actively working on their data. They don't want to see a productivity loss. They don't want to have to deal with restoring snapshots, which is, by the way, something we do really well, but you want to make sure that you can maintain a level of productivity where there's no data at risk, there's no data integrity issues whatsoever. So our locking capabilities have been built on the fundamentals of a Windows Server. So basically what we do, if you look at the way that we interface with the file system, is a user interfaces with the edge. It's an edge VM instance or running on a Windows Server, and interfacing with that virtual file share, which is a UNC path that you would normally access through drive mapping or DFS namespace. That edge is communicating with what we call a core instance, which is currently a VM instance, but soon will be migrated into more cloud-native technologies and container-based technologies. But our core subsequently interfaces with the CVO instance. So the CVO instance is basically where you have your SVMs and your SMB endpoints, and that's where you manage your data, that's where you manage your backups, that's where you associate different types of snapshot and data retention policies with that central data set. But CVO is basically where the file lock is taken out. So if a user from an edge location opens a file, what happens? The user navigates through their file share, obviously has authenticated, and double clicks the file, let's say a simple file like a Word document. The edge will communicate with the core, do a quick hash check to see if there's already a cached copy in the edge, yes or no. If there's not, we have to stream the delta differences over the wide area network to update the file in the cache. But we're taking out a central file lock on CVO on behalf of that user at the edge. And in that case, that user is guaranteed read-write access to that file if he is the first one to open up that file. If someone else from site B or another distributed location tries to open up that same file like a millisecond thereafter, they'll get a message that the file is in use by, let's say, Jaap in Amsterdam, where I'm based. And you get the prompt the same way as a Microsoft server would actually offer you, say, hey, you want a read-only copy of the data? Do you want to get a notification when the file is available for read-write? Or do you want to get merged the contents later and save a copy locally elsewhere? And if you click, I want to get a notification, we get the benefits of the SMB notify. And then let's say I make the change in Amsterdam, make some incremental updates to my document, I save it, I close it at the end of the day, and the other user receives a notification. This file is available for read-write. Do you want to open up the file? It basically triggers a rehydration for only the delta blocks over the wide area network between the core and the edge, and subsequently the user will get access to the latest and greatest version of the file and would then have the read-write lock that sits on CVO. And that makes this really consistent because all of the locking is built on centralized locking on CVO. That also helps if you have users that are accessing CVO directly. You may have an in-cloud process that basically does some sort of rendering or high-performance compute that accesses the file shares directly on the back end. Even if you extend the data out to cache locations, all of the locking semantics and principles are still maintained on a per file basis in a native fashion, as you would normally recognize from a Windows server or from an ONTAP system, to guarantee that level of integrity.
Integrity aside, how do you handle the performance problem? I know that that's one of the main issues with this distributed file locking is that there's going to be some performance issues because you got to replicate lock states and everybody's got to be aware of everything. How does CVEC do that?
That's a great question. I think that's where we're unique in the marketplace, because if you look at other solutions out there, they have to actively replicate data or metadata associated with the locking state to tell these controllers that are running proprietary file systems and emulations of Samba at the edge to say, hey, this file is unlocked by this user in that site. We don't have to do that because all of the locking state is managed and maintained at the central location. So if I'm in Amsterdam and if I have a file open, I don't need to know what files are opened by the users in New York or elsewhere, right? So I could have infinite scale at that point, and I'm not impacted by chattiness or the abundance of replication traffic that is required in all those other solutions in the marketplace. Replicating metadata for the state of the file system, replicating metadata, who has the latest and greatest snapshot, replicating ACL structures and NTFS permissions throughout my ecosystem of controllers. That is not required with Cloud Volumes Edge Cache because each edge is unique. I could have a 100 terabyte file set, and my edge in Amsterdam right here in my backyard could be a 1 terabyte cache. And your cache may be 10 terabytes depending on your active data set. I don't need to know about your cache, and you don't need to know about mine. So basically what happens in the cache stays in the cache, but all of the consistency is guaranteed by that centralized locking model. And because we're efficiently moving, using our streaming protocol over the wide area network between the edge and the core, it only takes us a couple of milliseconds to check whether or not a file lock is taken out and whether or not we can take out a file lock on behalf of that user at the edge, which makes this highly scalable and flexible and performant at the same time. And then in terms of performance, obviously there's a few secret ingredients, quote unquote, or secret sauce that enables the technology to move the data faster from a networking perspective, large windowing, streaming, compression, but we also leverage delta differencing capabilities. So if you have a large file that is being served from the data center or from the cloud, if you haven't touched that file in, let's say, 30 days, and 20% of that file has been updated elsewhere, you only have to fetch that 20% delta increment in order to update the latest and greatest version of the file in the cache and serve it to you as an end user. So there's intelligence built into our protocol that helps to overcome some of these performance bottlenecks that you would typically see with other solutions or solutions that do write through or write around technologies. For example, in Microsoft, you used to have branch cache and you have Azure Files and Azure File Sync. They use those types of semantics in order to be able to replicate data. We don't replicate, we really only cache, and we stream and compress over the wide area network to make it most efficient and highly performant as well.
If I'm understanding this correctly, it sounds like we're taking this notion of performance as perception, right? So our users are really going to be what dictates if something's fast or not. So if they're local to the data and it's fast for them, that's all we care about, because the back end can take a bit of time to go back if we need it to, because it doesn't really matter. I think the only place where that really matters is if you need two sites to have access to a file immediately. That might take a little bit of time for that to update. Am I understanding that correctly?
Yeah, that's correct. I think we leverage write-back caching capability to accomplish that. So if a user performs a large write on the local file system at the edge, we use the write-back cache, and we can use as much bandwidth as is available to us, or we can throttle the bandwidth between what we call the edge and the core in order to move that data in a write-back fashion. To your point, if you collaborating in real time on a large engineering drawing, so let's say we're working on this 3D model of a skyscraper that's about a terabyte of data, you are working on the doors and I'm working on the windows, I need to make sure that as much as possible, my metadata for the actual model itself is almost like synchronously replicated. And we've built in features in order to accomplish that, to provide for those types of collaborative workloads and workflows that allows you to move the data, not only in a write back fashion, but also prioritize that data as well to be written to the back end in real time. One of the things that I see in the field is, as much as we can obfuscate the impact of performance from the wide area network and keep that performance local to the users, where the users would interface with their files either on demand or through warming up the cache using our pre-population capabilities, you're kind of really taking the burden off the user and let the backend file system handle the writes, but also the commitments to the central storage platform that is used.
Earlier, you mentioned things like SharePoint and OneDrive and DFS. How does CVEC differ from those? Give me just the overview, the summary of how it differs from each of those different ways of sharing data.
I think the major difference is that we're talking about a real-time global file system. So all of your file shares that are centrally provisioned on CVO, they're being cached at the edge on demand or through pre-pop. It's always going to be the latest and greatest version of the file that you're going to access as a user. With DFS or DFSR, you're dependent on replication. You have no locking or no consistency in order to ensure that you always have access to the latest and greatest version of the file. With SharePoint, obviously, you got to move your entire data estate that you're managing into a structured working environment, which is then built on client-server technology in order to allow your users to interface with that data. So all of your locking capabilities go away. All of a sudden, you have to train your users to check in, check out. You have to adhere to specific workflows in order to get access to that data. And the performance issues are still there, especially in a global environment. So you may have changed the form factor of the data. You haven't really addressed the issue of having a local cached copy that you need for performance and consistency to be able to actively access that data as a user. So I think if you look at the market in general, I think caching is still a very unique approach for this specific workload, and it becomes more and more relevant as obviously distance still continues to exist. Bandwidth is growing. That's not an issue anymore, most of the scenarios, but the consistency and having this idea of a global file system that it looks and feels as a local file server is still very much relevant.
What about something like Avere? Like, how does CVEC differ from a product like that?
Yeah, that's a good question. And obviously we see there's a numerous amounts of solutions that are built like Avere, which are kind of designed to push a lot of data through the pipe. So using UDP-based data replication to just move as much data as possible. We see this use case most of the times between data center to data center type of replications or very specific workflows, i.e. the media industry that just doesn't bother. There's no issues with consistency. There's no requirements for file locking. There's no requirements for the semantics of a file system with authentication and authorization principles on the NTFS file system or permission structures. Avere and solutions like that are great technologies just to massively move large amounts of data through a UDP-based pipe. And that's basically a completely different use case. Our edge caching software is designed for the movement of data, but with the purpose of creating that single set of data in the cloud and the ability to cache, but also maintain all of the fundamentals around authentication and authorization, ACLs, permissions, central file locking, all that goodness.
Okay. So I know that if you're NetApp centric, there's also that obvious one that we need to talk about is flex cache, right? So ONTAP does have the concept of edge caching within ONTAP natively. And if you're using CVO, you have access to that. So talk to me about the differences between something like a flex cache versus something like CVEC, and why would I use one over the other in certain use cases?
I think both solutions really complement each other really, really well. Historically, FlexCache's primary focus has always been NFS. Over the last years, they've been adding SMB capabilities to it as well. Our Edge Cache software, our global file cache, has always been focused on SMB and has been really focused on the Microsoft world. So if you love managing ONTAP, and if you love the ability to leverage caching, FlexCache is a great technology. If you're dealing with file shares that are not only sitting on ONTAP, but also on other storage platforms of choice, then and you're managing a Microsoft-centric environment, our global file cache or edge cache solution that is part of CVEC is a great technology that subsequently enables that capability. It's built for Microsoft administrators, It's built on Microsoft technology. It's built for the Microsoft ecosystem, and therefore it fits really nicely into that SMB specific workload. I do see a lot of customers that combine those solutions, right? They want to have a specific workload on NFS at a specific distributed location. They may have other workloads or other file system requirements around highly collaborative environments and real-time file locking and all that capability that are native within the stack and have been for the last decade. That's where they want to use Global File Cache or the edge cache software that comes with CVEC.
So I know that ONTAP also can do multi-protocol NAS. So you mentioned NFS, and of course that won't work with Global File Cache or CVEC. So what about when you have data sets that are accessed by both NFS and SMB? So could I use CVEC for the SMB caching, even if there's NFS stuff going on the back end and other places?
Yes, you can. Obviously, the downside of an environment as such is that depending on the duality of the protocol stack on the back end, you may or may not benefit from file locking the way that you normally would in an SMB ecosystem as a whole. So yeah, there's considerations for that. We do have customers, for example, that leverage ANF in a dual protocol fashion and subsequently use the SMB portion of that volume to extend that out to the distributed locations using our GFC software. That's fully supported, but you can't really control what happens on the NFS endpoints.
So you've talked a lot about CVEC being a part of the Cloud Volumes ONTAP infrastructure. What if I've got a mixture? What if I've got some Cloud Volumes ONTAP, but I've also got a lot of on-prem stuff? And really, the reality is that a lot of our data sets are still on-prem and we haven't migrated them to cloud. How does CVEC interact with that sort of use case?
That's a massive opportunity we see there. I think 90% of my conversations with customers are exactly around that hybrid motion, right? We have our on-premises state of NetApp infrastructure. We've been managing that for many decades, and we do want to kind of expand that into the cloud, but we don't want to give up on our on-premises capabilities. So yeah, Cloud Volumes Edge Cache is really designed to deliver that hybrid multi-cloud approach. So think about bootstrapping your cloud landing zone, as I would call it. You create a cloud landing zone in the cloud. That's a file system. Could be 10 terabyte, could be 30, could be 100. That's your starting point. And subsequently, what you do with that file system, you unlock the capability of edge caching. So you now, as a user, can see that centralized file system. But you can also attach that end user to your on-premises data center, because by virtue of deploying and implementing Cloud Volumes Edge Cache, you automatically unlock the capabilities to integrate what we call our core instance with your on-premises infrastructure as well. So now we can extend the file shares that may sit on a FAS or an all-flash array out to that same distributed location. So as a user, I can see the files that are sitting centrally on CVO, that are sitting centrally in my on-premises data center in the same construct of the namespace, which really provides you that hybrid capability for different reasons, right? So data sovereignty or data residency. Some of the data may not be in the cloud, but I do want to present it at my remote office, branch office locations. Maybe the ability to provide for that idea of a cloud journey, not a lift and shift or say, hey, I'm going to migrate my data on Friday and I'm going to hope for the best on Monday morning, because we know the reality, if you're talking multi-terabyte, multi-petabyte scale, it's going to be a bit of a journey. So the ability to combine on-premises and then use our SnapMirror replication technology to move volumes and create that idea of data portability between your on-premises data center and the public cloud now gives you the options to move different volumes or workloads from one place to the other without disruption to the users. The users can still access the data as if it's locally through the cache.
Okay. So it sounds like we have a lot of opportunity here to use Global File Cache or CVEC in a lot of different areas. So I know you touched on CVEC being this encapsulating solution, including Global File Cache and CVO. What about Global File Cache itself? Like, when would we use something like that if we aren't able to use CVEC?
The idea around CVEC is that customers want to kind of burn down their hyperscaler monetary commits. So in Azure, you have what's called a MAC. So basically, a customer buys some upfront commitment with Azure. They want to spend that commitment through third-party or native services in Azure. And CVEC is exactly built to do that. So CVEC is what is called a marketplace eligible solution. So you can consume the technology, the whole stack of services through a pay-go or private offer model. That's a different way of consuming versus GFC, because GFC traditionally has been sold or positioned as a standalone solution that extends Amazon FSxN, Azure NetApp files, your on-premises data center, everything that is not CVO in Azure. And soon we'll have CVO and Google supported as well. But GFC is traditionally designed to support everything that is NetApp ONTAP and bringing that data close to the users at the edge caches. And that technology is still available today as a standalone solution, which is offered as a subscription by NetApp. So this is not, we're not selling that through the marketplace or as a private offer or whatsoever. We're selling that as a subscription. The way that customers buy has changed. I do have to say most customers are really excited about buying a platform that includes a cloud file system, that includes backup and data protection and recoverability options and caching and visibility as a single solution, either through pay-go or a private offer. That's what the major difference is. But for those customers that want to benefit from GFC or global file cache, it's still out there today. We continue to make updates to the technology. We recently introduced the capability of managing and monitoring your global file cache software through our Cloud Insights platform and release some cool dashboards to get you more visibility and telemetry to the platform. It's here to stay. So global file cache is standalone. If you're looking for a full platform opportunity and solution, Cloud Volumes Edge Cache is the way to go.
All right, Jaap, sounds like we got a lot to think about with global file cache as well as CVEC. It sounds like we've got a really good use case spelled out here and that we understand where everything fits so we know when to use what and when not to use it. So if you could, tell me where to find more information about Cloud Volumes Edge Cache.
Thank you very much. And I think we have a massive opportunity in front of us. Most of our technology is now available, especially in the cloud portfolio, through our BlueXP page, which is bluexp.netapp.com. There's different categories. You'll find category storage, mobility, protection, analysis, and control. Under mobility, you'll find edge caching, which basically gets you through both global file cache and our Cloud Volumes Edge Cache offering. So if you want to get started, go there. And otherwise, you can check us out in the marketplace on Microsoft Azure and in the near future on another hyperscaler that is very popular nowadays with us that we'll be announcing soon. So stay tuned for this. And thank you very much for listening.
A little teaser there.
All right, that music tells me it's time to go. If you'd like to get in touch with us, send us an email to podcast@netapp.com or send us a tweet @netapp. As always, if you'd like to subscribe, find us on iTunes, Spotify, Google Play, iHeartRadio, SoundCloud, Stitcher, or via TechOnTapPodcast.com. If you like the show today, leave us a review. On behalf of the entire Tech on Tap podcast team, I'd like to thank Jaap van Duijvenbode for joining us today. As always, thanks for listening.
Oh, yeah. Is it just me that's getting off on this? Oh, yeah.